Look into the sky at night. You'll see stars many miles away. But how do we know they're so far away? How do we find the distance? We will use an approach called parallax, which is when an object gets viewed from different positions. Put your finger an inch in front of your nose and close your left eye. Now open your left eye and close your right eye. You'll notice that your finger shifts despite actually not moving at all. This is because your finger is to the right of your left eye but to the left of your right eye. Now do the same thing but move your finger closer or farther away. You'll notice that the farther away your finger is, the less it shifts. This means that if we know the distance the finger moved and the distance between your eyes, we can theoretically find the distance from your eye to your finger. We can do something similar to find the distance to stars. Imagine a faraway star as a finger and the Earth as the eye. When the Earth moves from one side of the sun to the other, the star shifts a little. We can measure this shift and calculate the distance to the star. We know the distance between the Earth and the sun. It's called an astronomical unit, or an AU. We can measure theta, the angle the star shifts, using a telescope. Now we can find the distance to the star d using trigonometry. It is important to note that the distance between the Earth and the star and the distance between the sun and the star are almost the same. You can calculate either and get similar values. I will be finding the distance between the sun and the star. To use trigonometry, you need to form a right triangle. Let's say the Earth is at the following positions during these 4 months. If a star is at this position relative to the sun, you want to measure the parallax during March and September, since that forms a right triangle. For example, say we get our theta to be 1 arcsecond or 1/3600th of a degree. We want to use cotangent since cotan of theta is d over r. Cotan of 1 arcsecond is about 206,265. This means that d is 206,265 times the distance to the sun. In order to make these calculations easier, astronomers use a measurement called parsecs. A parsec is the distance to a star if its parallax is 1 arcsecond. From what we found, 1 parsec is 206,265 AUs. A general formula for calculating the distance in parsecs is 1 divided by the angle the star shifts in arcseconds. This means that we can find things in terms of parsecs. If the angle a star shifts is 2 arcseconds, its distance to Earth is half a parsec. The main limitation with parallax is that telescopes cannot detect small angles. The smallest angles that modern telescopes can detect are 0.000024 arcseconds. Using the formula from earlier, the longest distance we can measure is 40,000 parsecs. If a star is over 40,000 parsecs away, the angle it shifts when the Earth revolves around the sun will be too small for telescopes to detect, so we won't be able to measure its distance with parallax. As telescopes become more powerful, parallax will become more effective.